Welcome once again to today's lesson. So today we're going to continue learning outcome 3.38, but this time not on conversion graphs, but on distance time graphs, which you can find on page 17 of the notes. So let me explain what are distance line graphs, okay? So distance line graphs are used to show how far something travels in a certain amount of time. And this is an example of a distance time graph, okay? You can see that we have three parts, okay? This graph has three parts. And the x-axis represents the time, sometimes in seconds, sometimes in minutes, hours, okay? It doesn't really matter. But the x-axis represents time, while the y-axis, the vertical axis, represents the distance. Sometimes it is in meters, sometimes it is also in kilometers. So you need to take care of the units there. Now, what are these lines and what do they represent? So a straight diagonal line like this one, okay, shows that the object is moving at a constant speed. Constant speed is at a speed which does not change, okay? A constant speed. So this line here, we know that some distance is being covered, okay? Because from 0 we ended up to 50 meters, okay? In 20 seconds. So we know that during this section of the graph, okay, during this section of the graph, it took 20 seconds, okay, 20 seconds, and it covered a distance of 50 meters. Now, the second part of the graph, which is this horizontal line. During this horizontal line, we can see that time is passing, of course, because time always passes, okay? So time is passing, but distance is not covered. It started at 50, and it ended at 50, okay? So a horizontal line shows the object is not moving, okay? The object is not moving when we have a horizontal line like this, okay? So time is passing, but the distance is not changing. It remains 50 throughout. The third part of this graph shows another diagonal line, so we know that this time the object, a person or a truck or something, is moving again, okay? Is moving again. This time it takes this object another 20 minutes, 60 minus 40, sorry, 20 seconds, okay, 60 minus 40, 20 seconds to cover from 50 meters to 175 meters, okay? So in total it covered, during this part, it covered 1 to 5 kilometers. 175 minus 50 during this part only, okay? I'm focusing only on that part of the graph. Now, this is important. Do you remember the gradient of a line? We said that the gradient of a line represents how steep the line is. Now, the steeper the line, the faster the object is moving. So we can see that the gradient of this line is steeper than the gradient of this line, okay? If we compare them, okay, you can see that this line is steeper than this line. That shows us that during this period, the object is faster than during this period, okay? So that is also important. Now, let's take an example. So here we have a distance time graph. Let's read the question. So, Tom is a delivery person. On Tuesday, he leaves the depot at 8 a.m. to start his deliveries. So as we can see on the graph here, he started at 8 a.m. 08 represents the time of the day. 8 a.m. Okay? He first makes a delivery at town A, okay? Then one in town B, and then goes back to the depot. The travel graph represents his journey. So, as you can see here, let me explain a little bit the graph, okay? So, to arrive at town A, he took from here to here, okay? So, it took from 8 o'clock to 10 o'clock, okay? It took 2 hours. Then, he spent some time at town A because he needed to deliver these items, okay? So, he took some time at town A, and then he continued his journey to town B. So this is the journey to town B, okay? The steepness of the line, it seems that they are basically the same, but not necessarily. We need to check again about that, okay? Because maybe one of them is steeper than the other. So Tom went to town B, okay? So here he arrives at town B, he delivered his items, okay? So that's why he's not moving, okay? And then he went back to the depot, so he went back down, okay, to the depot, okay? So question A, at what time did Tom make the first delivery at town A? So town A is here. The first delivery at town A is at 10 a.m. Okay, at 10 a.m. How far is town A from the depot? So town A, these are distances in kilometers. So here it is 20 kilometers. Okay, here it was 0. So the distance from town A to the depot is, of course, 20 kilometers. At what time did he arrive in town B? He arrived in town B here. Okay, so you need to read the time on the x-axis. D. So let me explain that again. So town A is here. Okay, so you need to read the time on the x-axis. Question D. How long did he stay at town B? How long did he stay at town B? We know that he hasn't moved or he hasn't traveled during this time. Okay, so you need to check how much time was spent there. Okay, at town B. Question E. How long did the back journey from town B to the depot take? Of course, he left town B here. Okay, he left town B here, which was 3 o'clock in the afternoon. He arrived at the depot at 5 o'clock in the afternoon. So you can do some minus there. Question F. For how long did Tom stop throughout the whole journey? Remember that stops are represented with a horizontal line. For how long did Tom stop throughout the whole journey? Okay, so you need to add this part with this part. Okay, because it's where he stopped and throughout his journey. So that is page 18. As you can see, I haven't worked them out, but I have explained it in detail. Okay, you need to work this out. On page 19, you have another one. Okay, this time this graph represents the journey of Margaret. Margaret went on a cycle ride. The travel graph shows Margaret distance from home on this cycle ride. So distance from home in kilometers, it started, of course, 0. This line represents that she was cycling, then she stopped, okay, and then she went back home. And you have some questions that you need to answer over here. Question 3 on page 20, last page of the notes. Here we have another distance time graph, but this time it is not complete it. You need to complete it as per the questions. So, Jamie traveled 20 kilometers from his home to his friend's house. Jamie then spent some time at his friend's house before returning home. Here is the travel graph for part of Jamie's journey. So, here we have the distance from home in kilometers, okay? Here we have the time of day, okay? So here it is 10, 10:20, 10:40, 11, etc. So from here to here, it is 20 minutes, okay? 20 minutes have passed, okay? So we have 10 small boxes. So 10 small boxes represents 20 minutes. So every small box represents 2 minutes, okay? Every small box represents 2 minutes. And you have these questions. Write down the time that Jamie left home. Jamie left home here, so you need to figure out the time. What was the time here? Question B. Write down Jamie's distance from home at 10:20. So at 10:20, what was his distance from home at 10:20? Again, we need to read this time the y-axis, okay, when we meet, and read the y-axis. Question C. Jamie left his friend's house at 11:10 to return home. So at 11:10, okay, 11:10, which is here, he left his friend's house to return home. Work out the time in minutes Jamie spent at his friend's house. So we need in minutes how much he spent from here to here, okay, in minutes. Jamie returned home at a steady speed. He arrived home at 11:50. Complete the travel graph. So we know that he left his friend's house here, okay? So we need to start a line from there. And in the question, he told us that he arrived back home at 11:50. So you need to decide 11:50, where is it on the x-axis, and then join a line from here to the time at 11:50. Okay? And that's it. Okay, so that's all for this lesson. Okay? This lesson covers the total topic of straight line graphs, as from tomorrow we will start another topic. So bye for now, see you tomorrow.